This presentation is going to be on an Internet of Things based solid waste monitoring system. So, in this presentation, we're going to go through the introduction, literature review, proposed work, discussion, results, conclusion, and the future works. So, due to increases in population and urban development, many people are sharing the waste disposal bins around places such as institutions, apartment complexes, and other areas. Environmental threats such as illegal dumping of waste, littering, poor sanitation, and poverty have proven to be great contributors to the degradation of the environment and poor waste management. And this is mainly due to the fact that most people still tend to use these waste disposal bins despite them being full in a lot of different areas. So, this issue of waste management has therefore been taken as a serious concern for the Namibian government and as well as a threat to the integrity of the environment. Therefore, this study aims at providing a smart solution for monitoring and managing this solid waste. So, a lot of studies have been conducted in relation to monitoring solid waste, and one of the studies that we're going to look at uses wireless sensor networks and Argus D sensor nodes, which are placed on top of each bin for monitoring these bins. These Argus D sensor nodes are configured to send periodic data to a remote server, and this information or data that is sent to the remote server is used by an administrator for route planning through the aid of the decision support system in a software application. So, the main setback with this study is that it does not use a GPS sensor or GPS technology to be able to identify the location of each and every bin. Therefore, the administrator is responsible for inputting the location of each and every bin, which can be tasked. The next study has suggested the use of different algorithms, such as the shortest path algorithm, for optimized route collection of the bins. What mainly happens in this is that the use the use of artificial intelligence together with some other algorithms to be able to get the data, historic data of each and every bin, sends alerts to the administrator to avoid these bins from overflowing. So, in order to find a route that is well optimized, they use algorithms which make use of street segments as edges and joining points as vertices, and the street network graph to calculate an optimal route. So, the setback with this is that this means any change in these values affects the calculation of an optimal route. Since each and every update, such as changing the roads, let's say the road is changed, the road has been closed, these updates need to be made manually, and if not, then the route will not be an optimal route. The last study that we're going to look at makes use of technology such as RFID, GPS, GPRS, and GIS. So the system consists of an RFID tag that is mounted on top of a bin, an RFID reader in the track, a GPRS as a web server, and a GIS as a map server, and database and a control server. So with the aid of low-cost cameras, these low-cost cameras measure the volume of the waste that is presented in each bin, and the GPS networks are used to be able to find optimal routes together with the GPS for the truck driver. And with the use of the GPRS as well, the truck driver is notified on the exact location of the bin that is full, and they're able to do the collection process. Through the aid of the design science research methodology, the proposed system adopts some review techniques and technologies that were previously discussed. The solution is an autonomous system that uses Arduino microcontroller and other technologies such as the GSM for text messages, the GPS for location, and as well as the ultrasonic sensor for measuring the distance of the garbage. So the design of a proposed system consists of a power supply, which is used to power up the Arduino microcontroller, a GSM module that is used to send a text message, the Arduino Uno microcontroller, which is used to control all the other sensors, an ultrasonic sensor, which is used to measure the height or the distance of the garbage in the bin, and a GPS module, which is then used to get the exact location of the bin, and send it together with the GSM module in a text message. The system architecture of a proposed solution consists of a ultrasonic sensor that is placed on top of a bin. This ultrasonic sensor communicates with the Arduino microcontroller on the levels of the garbage in the bin. If the levels of the garbage are high, the Arduino microcontroller communicates with the cell phone through the GSM network and sends a text message to the phone of the truck driver. This text message consists of a Google Maps link, and the driver then uses this Google Maps link to find the exact location of the bin. The exact location of the bin, which is gained from the GPS sensor. So, at the remote site, the levels of the bin are sent to the web server, and these are kept in the database, making sure through the internet that at the remote site, the administrator is also able to see the measurements of the bin. So the flowchart here just shows the interaction between the remote user at the remote site, which is the administrator, and the web interface that has been designed to view the real-time garbage levels in a tabular form from the ultrasonic sensor measurements. So each user is then added to a database, and in this database, this user therefore gains access or access rights to the web interface that has been designed. So upon getting these access rights, they are able to log into the site and they can view the real-time data as well as log out and log back in when there's need. This is just a picture of the finished prototype with all the connections made and all the components as discussed in the design. So a low-cost prototype was developed by interfacing the Arduino microcontroller with modules and sensors such as the GSM module, the GPS module, and the ultrasonic sensor. And the combination of these sensors together with the Arduino microcontroller produced a system that was able to sense the bin levels using the ultrasonic sensor, and this data was processed by the microcontroller. And whenever a threshold of 80% was reached, an SMS was sent to the driver's smartphone. The picture here just shows an example of a message that is received or that is sent to the driver when the bin is full. This message consists of a Google Maps link that is generated from the GPS sensor that is connected to the Arduino, and through the use of the Google Maps link, the driver can then get to the exact location of the bin. The picture here shows a screenshot of a remote site that receives the information from the ultrasonic sensor, showing the garbage levels in a particular bin. And these are presented in tabular form in form of a bar chart to make it easy for the administrator to read or interpret the information. So the main aim of the study was to develop a prototype that automates the monitoring of garbage in bins and gives an alert when the threshold has been reached. And also, the aim of this study was to provide a platform for garbage monitoring. So the prototype that was produced gave in results that were very accurate and very impressive to the users. The system was also said to be a more efficient proposition to the solid waste management problem that is being faced in Namibia. Users were also able to monitor bins from a remote location and were given accurate readings in form of a bar chart. In addition to the work that has already been done, a route optimization algorithm can then be added to the system that will enable efficient collection of bins when they are full. Integration of artificial intelligence to the system will allow it to learn patterns of waste collection, and through prediction algorithm, they will be able to predict when likely bins are full or when bins are likely to be full. So adding features such as waterproof elements to protect the system from environmental factors, as well as renewable power sources such as solar or battery power banks, will be able to let the work be more environmental friendly or practical.